In this video, we are studying about the mensuration of trapezium. That's measurements in trapezium. We are talking about perimeters, areas, but majorly focused on area because perimeter is all about adding up all the sides of a shape, right? So we are focused on the area. So a trapezium is basically a four-sided figure, a quadrilateral, having two opposite sides parallel to each other, and the other two opposite sides not parallel to each other. It could come in this form or in any other form, but all we know is that for a shape, a quadrilateral, a four-sided figure, to be qualified to be a trapezium, it must have two opposite sides parallel to each other, and then the other opposite sides remaining are not parallel to each other. If they were to be parallel to each other too, then we are now talking about a parallelogram. Okay, so for the area of a trapezium, we have that it is equal to the half sum of parallel sides times height. So we add the two parallel sides, that is, for these shapes we have AB as the parallel side. So this length A plus length B times the height. For this, and the height must be perpendicular height, a height perpendicular to the parallel sides, of course. So for this one, we already have that this side is perpendicular, so this side is actually the height. For this one that doesn't have this side like this, so we have to trace and find a perpendicular height. Now let's get into some examples that will help us to see how to go about calculating in trapezium. And here we are presented with this question. A trapezium has two parallel sides of length 5 cm and 9 cm. If the area is 21 cm squared, find the distance between the parallel sides. So we are going to draw a trapezium so we can see clearly what this question actually means. So I'm going to just draw any shape that is a trapezium. So these are the parallel sides, right? The shorter side is 5 cm, the longer side is 9 cm. So a trapezium has two parallel sides, 5 cm and 9 cm. If the area is 21 cm squared, find the distance between the parallel sides. So we can see that the distance between the parallel sides is actually asking for the height of this parallelogram, right? And we've been given that the area is 21 cm squared. Now, what we have to do is to write out the formula of a parallelogram. So we have that area is equal to half of the sum of parallel sides, sum of parallel sides times height, right? So we are going to substitute what we know. We have that area is equal to 21 cm squared. So half sum of parallel sides, we know that is 5 plus 9, and then this height, the distance between the two parallel sides. Simple, right? We're going to open up the bracket, solve the fraction. We have 21 is equal to 5 plus 9, that is 14, right? So half of 14 is 7, so we have 7h remaining. We are dividing both sides by 7. You can see how easy that is, right? And then we see that h is equal to 3 because 21 divided by 7 is 3. So and it's in cm, the unit is in cm. So the distance between the two parallel sides, h, is actually 3 cm. Here we've been given this shape, a trapezium, and we have that the height is 10.5 cm, and we are told that the area is 73.5 cm squared, and we are told to find the length of this side PS if QS is 1/3 of PS. Wow, this is actually easy but looks challenging, right? So we're going to start from the last statement. PS is equal to 1/3 of PS. Okay, so let's call, okay, so we have that, no, QR, not QS, please, that's QR. as this length is one third of this. So we have that QR is equal to one third of PS, right? One third of PS. So this is the exact statement that QR is one third of PS, right? So, and we've been asked to find PS. So we're going to make, okay. So to find PS, okay, QR is already the subject formula here, right? Good. So we are going to go over to the formula for a trapezium, which is half, as area of trapezium is equal to half sum of parallel sides, sum of parallel sides times height. Okay, we are going to substitute immediately. The area is 73.5 cm is equal to half into sum of parallel sides. So QR, which is equal to 1 over 3 of PS, right? Plus PS itself, right? So like we formed the formula here that QR is equal to one third of PS. So this is representing QR plus PS. That is sum of the parallel sides. And then the height is 10.5 cm. Okay, we're going to open up brackets, right? Okay, so equal to half, one third, that is 1 over 3, right? 1 whole number, 1 over 3, because this is 1 whole number plus one third, that is 1 over 3 PS times 10.5. Okay, right now we are going to collect like terms. So these numbers, 2 is going to multiply and then divided by 10.5. So we have that over this side we have 73.5 times 2 divided by 10.5 is equal to one third of this. We're going to change this to improper fraction. 1 times 3, that's 3 plus 1, which is 4 over 3 of PS. So let's still go ahead and collect more like this. That's cross multiply, right? I know this is getting weird. That's because we wanted to solve without calculator. We have 73.5 times 2 times 3, because 3 comes up, all over 4 times 10.5 equal to PS. Okay, since we insist on solving without calculator, it's doable. So 2 times 73.5, that will give us 2 times 70, that is 140. Then 3 times 2, that's 6, and then 0.5 times 2, so 147, right? So we could work with this. It's easier to work that way. We have that PS is equal to 147 times 3 over 4 times 10.5, that is 42. And 7 can divide in between these two. Okay, so 7 here is 6, 7 here is 21, right? And 3 can go. 3 into itself is 1. 3 into this is 2. 2 into 21 is equal to 10.5. So PS is 10.5 cm. But we could as well shorten all this whole process by solving with calculator. But we'll be trying out our hand to show that solving without calculator is still feasible and very possible. Okay, we have this other question. So here we can see a trapezium, right? And we can also see a parallelogram, because these two sides are parallel to each other. These two sides are parallel to each other. So this is a parallelogram, this is a trapezium, this side is a triangle. Okay, so a combination of shapes. If the area of triangle QRS is 20 cm squared, find the area of trapezium PQRT. Okay, the final goal is for us to find the area of this whole trapezium PQRT. And now what we need for that is half sum of the parallel sides, in which we could get that sum of the parallel sides, because as this is a parallelogram, PQST is a parallelogram, right? So this side is equal to this side because opposite sides of a parallelogram are equal. So as here is 10 cm, here is also 10 cm. So we have found the length of this parallel side, and as well the length of this whole parallel side TR is 10 plus 8 cm, which is 18 cm total, right? Good. So we have the sum of the parallel sides, but the issue now is the height. We don't know the height of this trapezium. So we now look at what was given. The area of triangle QRS is 20 cm squared, and we have this side, the base. So we know that the area of a triangle is half base times height. So half of the base, which is given 8 cm, times height. So since we know the area, we get the height and then solve for the area of the trapezium. Easy now? Okay. We have, so area of triangle is equal to half base times height. So area of the triangle given is 20 cm squared, half the base is 8 times height, which is not known. So half of 8 is 4. We have that 20 is equal to half of 8, 4h. We divide both sides by 4. We have that the height is 5 cm. Therefore, height is equal to 5 cm. That's okay now. So we solve for the area of the trapezium. Let me solve that with this color of pen. Area of trapezium is equal to half sum of parallel sides times height. We have half 10 plus 18 times height. 10 plus 18, that is 28. Half of 28 is 14. 14 times 5, which is equal to 70 cm. 70 cm squared. It's an area, so per unit squared. So this example is going to help us to learn so many things about a trapezium and as well as a parallelogram, because we can see two parallelograms in this shape and we can see a very big trapezium, right? So they said if the area of parallelogram PQRS, let's find PQRS. So the area of this parallelogram here is 56 cm squared. Find the area of trapezium PQTS. PQTS. So the whole shape. Good. Now it's important for us to note that parallel lines cut equal distances at any lines they cross. What do we mean by that for this shape? As here is 7 cm, this place is also 7 cm. As this place is 7 cm, this other side is also 7 cm. Not minding our diagram doesn't show that, but as here is 7 cm, this place is 7 cm because these are two parallel lines. As they cut, these are two parallel lines, right? And these other lines are also parallel lines. So parallel lines always cut equal intercepts at lines which they cross. So if this is parallel to this and this is parallel to this, it cuts same distance here and same distance here because parallel lines are of equal distance forever, right? And same thing here. So we have that here is 7 and here is 7 cm. So that is one thing we learn from this. So this is 7 cm and this is 7 cm. That being said, another thing we have to learn from this example is that two parallelograms yes, two parallelograms that have same base and within same parallel lines. That is, they have same base and same height, of course. So that I'm referring to this parallelogram and this parallelogram. They are of equal area because they have same base, right? Because it's base times height, and they are within same height. So this same base times this same height, therefore they are of same, that is equal area. That's what we have to learn now. So having said that, what we have to do is now the area of a trapezium. That's what we are required to find. So area of a trapezium is equal to the half of the sum of the length of the parallel sides times the height. Now we have, from the knowledge we've just expressed now, we have found the length of the parallel sides of this whole trapezium, right? And then it's now the height. But for the height, we know that for a parallelogram, that the area of a parallelogram is equal to base times height. So this is the base times height. So since we've been given the area of the parallelogram and we know the base, we can find the height from that base and then use that height to now find the area of the whole trapezium. You can see it's easy, right? So we have that area of parallelogram, this is the short form of writing parallelogram, okay, is equal to base times height. So the given area is 56 cm squared and the base is 7 times height, which we are looking for. We divide both sides by 7. And when we divide both sides by 7, we have 8. We have that height is equal to 8 cm. Very, very easy. So we write out the formula for trapezium. Area of trapezium is equal to half sum of parallel sides times that height. Half, we have the parallel side 7 plus, then here we have 7 plus 7, that is 14. 14 plus 9, that is 23. So plus 23 times the height, which is given as 8. Okay, 7 plus 23, that is 30. Half of 30 is 15 times 8. Okay, 15 times 8 is 120. Equal to 120. So since it's an area, it's in per unit squared. So cm squared. Whoa,